Okay, today my lesson is going to be about heat and temperature. And I know that last time some of you were confused about how to set up the notes. This time I just want you to do notes just like you normally would, Cornell style. There's not going to be a whole lot to write, and you're just going to set it up with a skinny left column if you have any questions to write in there, and then a wider right side column, leave room for a summary. Don't forget to put the date on the top right corner. And this is going to go on page 15 in your notebook. Okay, to start with, what I want to do is remind you what kinetic energy is. Remember, kinetic energy is the energy of motion. And we can even talk about the kinetic energy of atoms and molecules in matter. Remember, the atoms and the molecules in matter are always in motion. And so we can say they have kinetic energy. Now, how fast those molecules and atoms are moving will depend on what state of matter it is. In solids, the molecules are going to be moving slowly. And if you remember, we talked about how they're jiggling in place. Jiggle, jiggle. In liquids, they're going to be moving faster. They're going to be sliding past each other and just kind of moving around. They're free to move. In gases, remember, they are zooming at high speed, zipping around. So the state of matter will tell you something about the kinetic energy of the atoms and molecules in that matter. One of the first things that we need to make sure you understand is the definition of temperature. Now, if you're like me, in your notes on the left side, I might write the word temperature, and then on the right side of the notes, I might write the definition. So the definition of temperature is how fast these particles move. Okay, the higher the temperature, the faster the particles move. So high temperature means fast-moving particles. Low temperature means slow-moving particles, and that includes for solids, liquids, or gases. So for some gases, the particles might be moving faster. That would be a higher temperature. For some gases, the particles might be moving slower. That would be a lower temperature gas. If we talk about the kinetic energy, temperature is defined as the average kinetic energy. Okay, so you do really need to write this as well as part of your definition for temperature in your notes, that temperature is the average kinetic energy of the particles in a substance. So if you could look at all those little particles and how they're moving around, if you could measure the energy of every single particle, add them all up and divide by how many particles you have, just like you would take an average, that would be the temperature. That's not really how we measure temperature, but that's really what temperature is measuring, which is kind of strange to think about, but that's how temperature is what it's actually measuring. Now, the tool we use to measure temperature, I'm sure you're well aware, is a thermometer. I wanted you to understand how thermometers work. Thermometer works because as substances heat up, they expand. Solids expand a little bit, liquids can expand more, and gases, of course, because they're free to change volume, expand quite a lot. And we've already talked about how gases can change volume and as they heat up. So because substances expand as they warm up, we can use that to measure temperature. And so what we do is we put a tiny little narrow tube inside the thermometer, and we put a liquid down in the bottom of the bulb. So the bulb at the bottom here has some liquid in it. As the temperature heats up, or as you place that thermometer into some kind of warm temperature, then the liquid has to expand. The only place it can go is up the little tube. And so as it rises up in that little tube, then it reads out whatever temperature it is. Of course, it has to be designed just exactly right so that the temperature it's reading is actually the correct temperature, and that takes some engineering. The thermometers that we use in class have inside of there, the liquid is an alcohol. It's a type of rubbing, I don't know if it's rubbing alcohol or some other kind of alcohol in there. And then, of course, you've probably heard of using mercury in a thermometer. In that case, the little bulb would be a silvery color instead of red or, blue or green. It would be a silvery color, and that would be the element mercury. It is a liquid, and those are very precise, a mercury thermometer. So in a science lab, they'd be using a mercury thermometer. But mercury, if it spills out, is potentially cancer-causing substance, so we don't use mercury thermometers in class at all. The second term I want to define for you today for your notes, and again, if I were you, I would write the word thermal energy in that skinny left column of your notes, and then the definition in the right side column, but you can do it however you want. Thermal energy is defined as the total of all the energy of all the particles in a substance. Notice the difference. Temperature is the average. Thermal energy is the total of all the energy of all the particles in a substance. So, of course, thermal energy is going to depend on, you guessed it, mass. The more you have, the more you have. The greater the mass, the more the thermal energy. So thermal energy is the sum total of all the energy of all the particles in an object. Thermal energy and temperature are related, but remember, they are not the same thing. Temperature is the average, and thermal energy is the total. So a bathtub full of water at 100 degrees Fahrenheit, nice warm bathtub, has more thermal energy than a thimble of water at the same temperature. Okay? The temperature is the same, but the total amount of energy is different because the bathtub has more water in it. The bathtub has more energy. So I want you to think about this. A boiling hot cup of tea actually has less thermal energy than a bathtub full of cold water. That's weird to think about, but the boiling hot cup of tea has a much, much smaller mass than a giant bathtub full of water. And so when you add up all of the thermal energy, the bathtub is actually going to have more thermal energy because of all those particles. All right, that's all I have for you for today. Hopefully you took notes real well on page 15, and have a good day.
Made with Doodlecast Pro.